We're talking about infinite series, and this is a type of series. It's called a telescoping series. The general form you see here is b1 minus b2 plus b2 minus b3 plus b3 minus b4, and these things tend to be fractions. They don't have to be, but the b's tend to be fractions. Now if you look at what happens, here we have a negative b2 and a positive b2, so they just end up canceling out. And you have a negative b3 and a positive b3, and they just end up canceling out. And that pattern would continue, and everything would cancel out except for this right here. So first thing I want to make sure you know is that telescoping series always converge. So as soon as you can identify that it is in fact a telescoping series, you know immediately it converges. No questions asked. But telescoping is also one of the types, along with geometric, that we can find the sum. So I want to show you how to do that. So this first example, we have 1 over n minus 1 over n plus 1. And what I'm going to do now is basically what we call expanding. I'm actually going to plug in the values and start finding the terms. So if I plug 1 in for n, I get 1 over 1 minus 1 over 2. That would be my first term. That's what happens when I plug 1 in here and 1 in here. So I get 1 over 1 minus 1 over 1 plus 1, which is 2. Now I need to add to that what happens when I plug in 2. So now I plug 2 into n in both places, and I get 1/2 minus 1/3. Plus, now I need to plug in the 3, so 1 over 3 minus 1 over 4, plus, now plug in 4, 1 over 4 minus 1 over 5, and so on. I think that's enough to get the hint there. So you could keep expanding as long as you want, but these things are going to just keep canceling out, because if you notice, you have a negative 1/2 and a positive 1/2, a negative 1/3 and a positive 1/3, a negative 1/4 and a positive 1/4. And if you continued to cancel out, you would see that the negative 1/5 would cancel and everything after that would cancel. So all that's left, the only term that doesn't cancel, is the 1. So our sum would be 1. Because we know automatically, just because it's telescoping, that it's going to converge. So we can also find the sum. In this case, it's 1. Okay, just to kind of anticipate a question, it will not always be just the first term that's left over. Sometimes you'll have more than one term left over, and if that happens, you just add those terms together. I think the first term will always stay, but there could be more than just the first term that stays. And we should see an example of that in just a moment. Okay, so this example right here. Now this may not look immediately telescoping. After all, there's just one term. And if you look back at the general form in the example we had one term minus another term. Well, if you remember back to what we've done just a little while ago with fraction decomposition, or partial fraction decomposition, there is a way for us to rewrite this. So if you notice, the bottom can be factored as 2n minus 1 times 2n plus 1, which means we can split it into two fractions, a over 2n minus 1 plus b over 2n plus 1, and use that to find the values of a and b. So I'm not going to go through this real carefully because we've done this before, but basically multiply everything that I've written in blue by the common denominator, and you end up with this. Because I'm multiplying everything by 2n minus 1, 2n plus 1, 2n minus 1, 2n plus 1, 2n minus 1, 2n plus 1. So that cancels that out there. That's why the b's times 2n minus 1 cancels that out with a, so you end up with a times 2n plus 1. Cancels everything out over here, so that's why you just end up with 2. So now's the part where we plug in values that will make the 1p 0. So I could try negative 1/2 and get 2 equals a times 2 times negative 1/2 plus 1 plus b times 2 times negative 1/2 minus 1. Okay, so if you notice, this ends up negative 1 plus 1 right here, so that just gets wiped out because it's 0. You get 2 equals b times negative 2. So b is equal to negative 1. Now if I plug in a positive 1/2, I get 2 equals a times 2 times 1/2 plus 1 plus b times 2 times 1/2 minus 1. So that gives me 2 equals a times 2 plus b times 0. So that just cancels, and we get a equals 1. So this thing that we originally had, the 2 over 4n squared minus 1, we can now rewrite this way. 1 over 2n minus 1 minus 1 over 2n plus 1. And this minus right here is coming from the fact that b was equal to negative 1. So when I used this, oops, sorry about that. When I used this, that gave me a negative. Okay, just so you know, you always want to put the negative 1 second. Back when we were doing integrals, it didn't really matter, but with the series, you always want to put the negative 1 second. So you always want it the front one positive minus the second one. You don't want negative the front one plus the second one. So make sure it's always negative in the second one. Okay, now if we expand this, I'm plugging 1 in for n, so I get 1 over 1 minus 1 over 3. Plus 1 over, if I plug in 2 now, I get 1 over 3 minus 1 over 5. Plus, if I plug in 3 now, I get 1 over 5 minus 1 over 7. Plus 1 over 7 minus 1 over 9, and so on. Again, I'm just plugging in 1, then I'm plugging in 2, then I'm plugging in 3, then I'm plugging in 4, and so on. And if you notice, these cancel. The negative 1/3, positive 1/3, negative 1/5, positive 1/5, negative 1/7, positive 1/7, and you can bet that as from then on everything cancels out. So we are again just left with a positive 1. So we know this converges because we saw it was telescoping, automatically converges, and its sum would be 1. So I want to kind of give you a guiding principle, and then I'm going to show you one that doesn't just leave the first one. So first of all, the back terms, so here's what I'm calling the back terms. If you look back at this example, I'm going to circle all the back terms in red. So basically they're all the ones with minus. You can call them the second terms, I just call them the back terms because they're at the back of the fraction. The back terms will always cancel out. As long as you expand far enough to see it, then the back terms will always cancel out. There's no way around it. It'll always happen. And as soon as one of the front term cancels, all the rest will from that point forward. Okay, if you look back here at the front terms I had, I'll underline them in green. Okay, the 1 stuck around, but the 1/3 got canceled, and then everything after that got canceled as well. So the back terms will always cancel out, and as soon as one front term cancels, all the front terms from that point on will cancel. So that's an important thing to remember when you're expanding. Okay, next thing, if we have one that looks like this. Let's watch what happens when we expand this one. It is telescoping, so we know it converges. So let's see if we can find the sum. Okay, if I plug in 1 first, I get 2 over 1 minus 2 over 4. Plus, okay, now if I plug in 2, I get 2 over 2 minus 2 over 5. And just, if you want to reduce these things, you can. I wouldn't recommend it. I think it's just more work. You certainly would want to reduce your final answer, but I wouldn't worry about it before that. Okay, so then I plug in 3, I get 2 over 3 minus 2 over 6. Plug in 4, I get 2 over 4 minus 2 over 7. Plug in 5, I get 2 over 5 minus 2 over 8. And I think that'll be far enough to make our point. Okay, so I told you the back terms will always cancel out. So we know this negative 2/4 is going to cancel out. And it's going to cancel out with the positive 2/4 right here. So that cancels. Okay, I don't see anything to cancel out the 2 over 1. I don't see anything canceling out the 2 over 2. Let's try the negative 2/5. Okay, that's good. That cancels out right there with the positive 2/5. 2/3, I don't see anything canceling with that. The negative 2/6, well, I know the back terms are all going to cancel out. If you just wrote one more term over here, you'd find that. And then if you notice, I finally had a front term cancel. So if you go with the principle I just wrote back here, the back terms will always cancel out, And as soon as one front term cancels, all the rest do. So we can guarantee these cancel, and everything after the point I circled is going to cancel. So that leaves us with 3 spots. 2 over 1 plus 2 over 2 plus 2 over 3. So that gives us 2 over 1, 2 over 2, 2 over 3, which gives us 2 plus 1 plus 2/3, which would be 11/3, or 3 2/3. Let's see, 2 plus 3, 9/3. Yes, there we go. So 11/3. So I just want to make sure you saw an example where where more than just the very first term was left over.